Hello guys, welcome to our class for today. This is My Science Online, and this is your physics video tutorial, and you are welcome. And you are welcome once again. Please, if you are just visiting our channel, this is your online video class. Okay, so I will encourage you to go through our playlist. We have uploaded a lot of video classes, and then please subscribe to our channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, if you like what we are doing, give us a like, give us a thumbs up, give us a positive comment so that you'll continue to encourage us. Then if you have any challenge, please don't hesitate to reach us through the WhatsApp number that is showing on your screen, or click on the WhatsApp link that is under this video, and it will take you straight to our WhatsApp chat group where you can post any problem. Then we'll look at it and then see how we can assist you and help you out. Okay, so for our class for today, we'll be looking at magnetic and non-magnetic substances. We'll also look at temporary and permanent magnets, methods of making magnets, and then we'll also discuss demagnetization, magnetic properties of iron and sea, and then we'll now conclude with some few discussion on neutron point, magnetic flux, and magnetic potential. Okay, so that is what we are going to be covering in this particular class. Alright, so please get your writing materials ready so that we can go straight to our class for today. Right? Magnetic and non-magnetic material. Okay, so materials that are attracted by magnets are known as magnetic substances. Example are iron, steel, nickel, cobalt, manganese, alloy of metals, and so on and so forth. These are also called ferromagnetic substances. Materials that are not attracted by a magnet are called non-magnetic substances. Examples are glass, wood, rubber, tin, aluminium, and they are also known as non-ferromagnetic substances. Okay, so the area around the magnet in which it can attract or repel objects, or in which a magnetic force can be detected, is called the magnetic field of the magnet. We've discussed it before when we discussed magnets or a magnetic field. Okay, so this is what magnetic and non-magnetic material is all about. So now we're looking at, amongst this material, there are some that you can use to produce temporary magnets and permanent magnets. Okay, so that's what we're going to be looking at now. So materials that are easily magnetized and easily loses their magnetism, they are known as soft magnetic substances. Example is iron. They are used as temporary magnets. The materials that are not easily magnetized and do not easily lose their magnetism are known as hard magnetic substances. Example are steel, nickel, and cobalt. They are used for making permanent magnets. Temporary magnets are magnets that do not retain their magnetism for a long time. Once the source of the magnetism is removed, the magnetism in the magnet disappears. Example of such material is iron. So we have said that iron is a soft magnetic substance, and we also said that iron can be used to produce temporary magnet because they do not retain their magnetism for a long time once the source of the magnetism is removed. Permanent magnets are magnets that retain their magnetism for a long time after the magnetic source is removed. So materials for making such magnets are steel, nickel, cobalt, and so on and so forth. Is that okay? So that is temporary and permanent magnets. So method of making magnet, we have the electrical method of making magnets, and this method uses the magnetic effect of an electric current. The material to be magnetized is placed inside the solenoid as shown in this diagram below. So it could be iron or steel, as the case may be. Don't forget that for steel you produce a permanent magnet, then for iron we produce a temporary magnet. So when the direct current flows through the coil for a few seconds, the bar will be found to be magnetized. The polarity of the magnet depends on the direction of flow of current in the solenoid. If the current flows anti-clockwise direction, the end of the specimen is a north pole, but if the current flows in a clockwise direction, it is south pole. So for this particular case, this is the direction of flow of current. So this end is a north pole, and then this is a south pole. Alright, so this is how to produce magnet using the electrical method. Okay, so other method for producing magnet is the single touch stroke method or the divided touch stroke method, and this method they are under the contact method for producing of a magnet. So you have the electrical method for producing, for making of magnets. You also have the contact method for making of magnets. Okay, so as I said, you have the contact method or stroke method of making magnet, and there are two types. You have the single stroke or the divided touch stroke. So for the single stroke, the bar or the specimen that you want to magnetize is placed on a bench. So assuming this is the specimen that you want to magnetize, the specimen is on stroke along its length using end of a bar magnet. The magnet kept in an inclined position is dragged along the specimen from A to B, lifted well away and brought to A again. The process is repeated several times. It will be observed that the end A of the specimen will be the same polarity as that of the stroking pole, and end B will have an opposite polarity as that of the stroking pole. So what that simply means is that this is what you want to magnetize, AB. This is the magnetizing agent, right? So it is placed at it is inclined at an angle and stroke from end A to end B. When it gets to end B, you don't just return it to end A, you lift it up away from the magnet and then return it back, and then you stroke again. You lift it up, return back and stroke again continuously for several times. It will be observed at this end, if the end that you are using to stroke is not, if it is a north pole, then this end will have north pole, then this side will now be south pole. Okay, so this is the single stroke method. Now the divided touch method is just the same thing with the single stroke method. The only difference is that in that particular case you have two magnets. So you have two magnets with opposite poles that are used to carry that one out, but it is the same method that you are using for this single stroke that you use for that divided touch method. Alright guys, so this is the method for making magnets, electrical method and contact method. Alright, so I hope this is clear and there is no ambiguity in it. Now sometimes, depending on the way you handle your magnet, it can lose its magnetism. It can lose its magnetism, and that is what will bring us to demagnetization. Okay, so what is demagnetization? This is the process in which a magnet is made to lose its magnetism, and this can be achieved by one, electrical method. The magnet is placed in the solenoid, and then instead of a direct current passing through it for making the magnet, an alternating current is passed through it, and then the magnet is withdrawn from the solenoid in an east-west direction. the magnet will lose its magnetism. Another method of demagnetization is by mechanical method. This involves hitting or dropping the magnet on the floor several times while pointing it in the eastward direction. The magnet will lose its magnetism. Another one is heating method. When magnets are strongly heated, they lose their magnetism. So these are the three methods of demagnetizing a magnetic substance. Okay, these are the three methods of demagnetizing a magnetic substance. So what are the magnetic properties of iron and steel? Iron is more easily magnetized than steel, but it also loses magnetism more readily or quickly than steel. Iron produces a stronger magnet than steel when subjected to the same magnetic force. Steels are used for permanent magnets, while iron are used for temporary magnets, and they form the core of electromagnets. So most of the electromagnets you see, they are made with an iron core. You hardly see an electromagnet that uses a steel core. They use iron core. Electromagnets, you see them in different motors. Okay, you see them in different motors. All your motors, all your electric motors that you use to drive different engines, the rotating part is your magnetic core, is your iron core, right? It is your iron core that is the rotating part. So if you bring out the core of every rotating equipment, even your generator, if you bring out the coil of a generator and you bring out the armature that is inside, it is this soft iron core that is there. Okay, the characteristics of magnetic lines of force. One, they originate from the north pole and end on the south pole. Lines of force do not intersect or cross each other. Areas of lines of force with close lines have greater field intensity than widely separated lines. Alright, so I think this is clear. Neutral points, magnetic flux and magnetic potential. Okay, so the neutral point is the point at which the resultant magnetic flux density is zero. So if you have a bar magnet and maybe you have if you have a bar magnet and then you have a you have two like poles. So if this is not and this is not, definitely you know that you are going to be having a repulsion. Okay, so you have a repulsion, because since they are like poles, you will not have an attraction. So you have a repulsion like this, you have a repulsion like that. Cool. All right, so your arrow go out just like that and then that. Okay, you can draw this yourself, so I'm just trying to explain what a neutral point. This point here is called a neutral point. I'm just trying to explain a neutral point for you. So this is a neutral point. Is that okay? So you can relate with this. So at this point, the horizontal magnetic flux density is zero. Okay, at this particular point I see here, the resultant magnetic flux density is zero. So that is what a neutral point is. And then magnetic flux density is the ratio of the magnetic field lines of flux to the cross-sectional area. And that is what we have here. The unit of magnetic flux density is Weber. The unit of magnetic flux density is Weber. Magnetic flux all over area is equal to magnetic flux density. The magnetic potential is the measure of the work done in moving a north pole from infinity to that point under consideration. Alright guys, so I hope these points are clear and you were able to follow through. So in this particular class, you've learned what is you have learned what is you have learned method of making magnets, magnetic and non-magnetic substances, temporary and permanent magnet, method of making magnet, electrical method and contact method. Then you've learned what is demagnetization, uh, magnetic properties of iron and steel, and the neutral points and magnetic potential. Okay, so uh, I think this is where we are stopping this particular class so that we can have some other time. So please guys, thank you so much for your time, and we hope to see you in our next class. But before then, if you have not subscribed to our channel, please subscribe to the channel. Click on the notification bell so that whenever we upload a new video, YouTube will notify you, right? This is NonMagnetic Tutors Online, and we are your online physics tutors. Reach us through our WhatsApp link. Give us a positive comment, give us a like, give us a thumbs up, right? So we appreciate the fact that you've been with us. Invite your friends so that they can come and enjoy what you are enjoying. So thank you so much. Have a nice day and see you in our next class.